Alright, so we're talking about operations on functions today. And so we're going to start with two functions that we're going to look at. F of x is 3x minus 1, g of x is x squared. And we want to look at some notation for how we can combine these. So the first is our sum. So parentheses f plus g of x means f of x plus g of x. So if we were to take our values and just add them together, we would try to combine like terms. In this case, there are none. So that is our final answer for the sum of them. The difference is almost the same thing, except in terms of adding, we subtract. So we subtract our functions and go from there. Product, we would multiply. And we want to be kind of careful about how we're doing with our functions in terms of multiplication. As I multiply these, I need to add my parentheses. So it's the whole function f of x times the whole function g of x. It gives me my product. Difference is going to be similar. I divide them. So f over g of x, and I have a potential error if g of x is 0. So we have a caveat that g of x is not equal to 0. So those are the basic four, and then we're going to look at the one that's a little bit trickier, which is the composition of functions. So a composition of functions basically is we're taking one function and we're plugging it into another function. So if we take our functions again, 3x minus 1 and x squared, we have our notation of f open circle g, not to be confused with the multiplication where it's a closed circle or a dot. What this means is we take function g and plug it into function f. In our case, we're going to take the x squared and we're going to put it where we see the x in function f. So it becomes f of x squared, because that's what g of x is. It's x squared. We evaluate function f where f says take what's in the parentheses, which is an x, multiply it by 3 and subtract 1. That's our rule for function f. So if the x squared is in the parentheses, I multiply by 3 and subtract 1. So that is the composition of x and g. If we turn it around, what it means is I'm going to take f of x and plug it into function g. So it becomes g of x minus 3x minus 1. And the rule for g is take what's in the parentheses and square it. So if I take what's in the parentheses and square it, I get 3x minus 1 quantity squared. And expand it to 9x squared minus 6x plus 1. And we want to note that it's not commutative. We can't compose two things and switch the order around and get the same thing necessarily. So we want to keep that in mind, especially as we look down the road at inverse functions. All right, we're going to talk real quickly about domain and range and how this works for our functions. So if we're given domain and range, remember, domain is what we plug in, range is what we get out. So we have inputs and outputs, and we're going to look at this in terms of set notation. So remember, a function is a set of ordered pairs where one input gives one output. So in this case, we have a function where I put in 1, I get out 4, I put in 2, I get out 3, I put in 5, I get out 6. And we have another function g, where I put in 4, get out 7, put in 3, get out 8, put in 6, get out 0. And if I was to look at the domain of f, so those are the numbers I put in this case, 1, 2, and 5. And I look at the range of f. So what I get out, 4, 3, and 6. I have a mapping, 1 goes to 4, 2 goes to 3, 5 goes to 6. Now, if I want to look at the composition of g and f, what's going to happen is I'm going to take the values, f of x, which is the range, I'm going to plug those into g. So my range of f becomes my domain of g. So that becomes my domain of g. So if I put 4 into g, I'm going to get out 7. If I put 3 into g, I'm going to get out 8. If I put 6 into g, I'm going to get out 0. So that becomes my range of g. So I start with the domain of f and I end with the range of g when I compose these functions. So I have my mapping that continues. So for my total ordered pairs for the composition would be 1, 7, 2, 8, 5, 0, where that intermediate step deals with the range of f becoming the domain of g. So that whole thing is my composition of g and f. Now, let's say that we turn it around, g of f of 2. Well, f of 2, right, is 3. So that's g of 3, which equals 8. Turn it around, do f of g of 4. g of 4 is 7. And f of 7, well, it doesn't exist in our set. So we have something that's not possible. So it's something we need to be aware of, especially when dealing with ordered pairs, that we can't just necessarily turn it around and get a value that works. As we go further with inverses, we'll see how that works as well. But just the big idea here is we're taking a function and putting it into a function, and our domains and ranges are related, where the domain of the first function gives the range of the first function, which becomes the domain of the second function, which flies into the range of the second function.